I'm Matthew Hancock. I'm a partner at Veryst Engineering. We're an engineering consulting firm. We come to the COMSOL conference because we're certified COMSOL consultants. And we come here to find out what's new in the latest release of the software, to share how we're using multiphysics simulation and combining that with our subject matter expertise to help our clients across industries develop products and processes. So I'm excited to learn what's new and meet our colleagues both at COMSOL and in industry.
And my name is Mike Kuron. I'm also a partner at Veryst Engineering. Veryst is proud to be a platinum sponsor of this year's conference here in Boston. So we have a keynote given by Matt, and then we have a number of posters that we presented at this year's conference that cover various areas of our expertise, from fluid mechanics to heat transfer and electromagnetics in industries such as pharmaceuticals, chemical manufacturing, and soft robotics.
I'm giving a keynote this afternoon at the COMSOL conference about driving innovation with multiphysics simulation combined with subject matter expertise. And this, we have examples from clients across industry. Some of the takeaways are good simulations require good properties. If you're developing a solid mechanics simulation, you want to make sure that the material properties are accurate, because often properties you might find in the spec sheet will not provide accurate material behavior, and therefore your simulation will not be predictive. So we do a lot of in-house mechanical testing of materials. We select the appropriate material model, we calibrate that model, and then we often will run simulations with those models. So we're simulation and testing people working together to provide good material data for simulation people. So that's one of the takeaways. Another is all the great uses of COMSOL. So we have used it to show credibility of intellectual property. Some of our simulation results go into US patents. They can also be used as a novel application with 3D Biolabs, and this was published last year in PNAS, about using COMSOL to make a fractal geometry that allows us to script an algorithm and then use COMSOL as kind of our CAD modeling tool to then spit out geometry that's repeatable, parameterized, and then we can use simulations in COMSOL to optimize the design.
So some of the posters that we're presenting this year at the COMSOL conference include wireless charging, so a topic that's very popular with everything from consumer electronics to electric vehicles, and optimizing wireless charging systems both for efficiency and fast power transfer is an area where COMSOL Multiphysics can really excel in guiding design and innovation. Another area is in electrification, so specifically in electrification of chemical processes where electric signals and electromagnetic energy is used to provide process heat for driving chemical reactions such as steam methane reforming for hydrogen production. And so that's an area where, again, a code like COMSOL Multiphysics can be used to couple electromagnetics, heat transfer, fluid flow, and chemical reactions to both design and optimize really complicated multiphysics systems. A great example of this would be our collaboration with General Fusion. So General Fusion is a company working towards developing their magnetized target fusion machine with the goal of reaching scientific break-even. We've worked with them, and we highlighted this last year's conference, again this year, and publicly through a number of papers on our collaboration to both test and calibrate a constitutive model for solid lithium. And so we flew out to General Fusion. We brought our test capabilities to test lithium at the relevant temperatures and strain rates seen in their machine. And then together with General Fusion, we integrated that into a COMSOL Multiphysics model, which simulates the compression of a solid lithium liner in their fusion machine to design both the compression cycle, the physical components, and understand the sensitivity of those component designs and its sensitivity to the final result in compression timescales. So this type of project that we've done with General Fusion is certainly unique to their particular design and process, but it's something that Veryst does every day of the week.